Okay, here is our example 7. Now taking a look at this, again, as always, we think about continuity differentiability before we start. That this right here, we have the product of two continuous functions, square and a cube root, so that doesn't affect anything. So f is continuous. However, and the domain is negative infinity to infinity. However, we do have some concerns. Because of that 2/3, I'm going to say that there is a cusp or vertical tangent alert. So I'm going to make sure I take a look at the first derivative and see if it's continuous or not, see whether or not I have any problems with the differentiability. So we are going to take a look at that first derivative and the formula. So again, we want to sketch, find relative extrema and inflection points. A lot of practice with the same thing on this section. So go ahead. Now I'm going to have to use the product rule on this, and also careful here, you're going to have chain rule because you do have composition there as well. So we're going to take a look. Let's find our first derivative. F prime of v would be our second times the derivative of the first plus the first times the derivative of the second, 2/3, 6 minus v to the negative 1/3 times negative 1. And right there would be a mistake. That is an easily made mistake, forgetting that chain rule that's there. I'm going to go ahead and I'm going to factor to get this in a good form. I'm going to pull out the 6 minus v to the negative 1/3. Remember, you always want to pull out to the smallest power. 2/3 minus negative 1/3 would be to the first, so 6 minus v. And then we're pulling out the 6 minus v to the negative 1/3. I have a negative 2/3 v left, so minus 2/3 v. And then cleaning that up is going to give me a fraction. I don't really need to write that, but I'm going to. This would be 3/3, so minus 5/3 v plus 6. I was going to go ahead and make that into a single fraction. Let's back that up for a second. So 6 minus 5/3 v over, I'm going to move that to the bottom, 6 minus v to the 1/3. Now, the minute I look at that, since I see that my derivative is not defined at 6, we know that this is f is not differentiable. And I'm going to come back over here and be like, hey, we definitely have a cusp or a vertical tangent on the original one at 6 because it was continuous there, but yet it was not differentiable there. So we want to keep that in mind. So we're going to do our possible maxes and mins, our critical values. Our f prime equals 0 when the top equals 0, or when 5/3 v equals 6, v equals 18/5. So we're going to have that critical value, and then also the critical value where it does not exist. Because remember, a cusp especially can be a max or a min, so that's still going to be a critical value. And that's going to happen at when v is equal to 6. So v equal to 6. So we're going to go ahead and we're going to do our sign chart for this and see what we have. 5 goes into that's 3 something, so 18/5 is down here. Then we have our 6, and we want to go ahead and run our test. This is going to be, we're going to have to just do a plug and chug. So let's plug in 0 would be 6 over 6 or 1, so that would be positive. And so that's your derivative. And then we were 18/5 was 0. And then in between here, remember I said this was 3 something and 6, so let's pick like 5. If I put in 5, 25 over 3 is bigger than 6, so that's negative. And then put in 5 here, that's positive, so that would be negative. And then pick a number out here that's pretty large, like, I don't know, 100. Let's make it, it's going to be a negative over a negative, which is going to be positive again. So f is increasing, decreasing, increasing, and what you get now is our relative extrema. So f has a relative max at x equal to 18/5, and that's because f prime switched plus 2 minus, remember I always got to get the reason, and f has a relative min at x equal to 6. And I'm going to go ahead and call that as a cusp because I have a max and I have a D and E there. So I'm going to be like, that's a cusp, so keep that in mind. F prime switched minus 2 plus, just keeping that in mind for when we do our sketch. So then we come down, let's find our second derivative. And for our second derivative, we are going to need to use the quotient rule. And that's what I would do because I think that might be a little easier in terms of simplifying. So we would take our low d high, which is going to be negative 5/3, minus our high, 6 minus 5/3 v, times the low, the derivative of the low d high minus high d low. So that would be times 1/3, 6 minus v to the negative 2/3. Don't forget chain rule, times -1, all over the bottom squared, 6 minus v to the 2/3. We are going to need to factor, so we're going to go ahead and looking at our terms, I'm going to pull out a 6 minus v to the negative 2/3. I'm also going to pull out a negative 1/3 because that's, I've got to divide by 3, a divide by 3, and a negative and a negative. So let's pull out the negative 1/3 as well. All right, so that's going to leave me with here 1/3 minus negative 2/3 is going to be 6 minus v times, I took the negative 1/3 away, so times 5. Here we're going to have minus 6 minus 5/3 v. I took the 1/3 and the negative, and I took this out. So that's going to be what we have left there. Be careful with this distribution of the negative. 6 minus v to the 2/3. Okay, let's simplify a little bit more here. I can combine these together, and remember you're subtracting, so it's negative 4/3 and then it ends up going back into the bottom. So this is going to be a negative on the top. I'm going to go ahead, put the 3 down. 6 minus v to the 4/3. Then we need to simplify in here, so you're going to have 5 times 6 is 30, minus 6 is going to give me 24. And then minus 5v plus, I'm going to do it over here real quick because I can't do it in my head, minus 5v plus 5/3 v, which is going to be minus 15/3 v plus 5/3 v, so minus 10/3 v on that for our derivative. All right, so now we're going to find our possible points of inflection. So our possible POIs are going to occur at 6, at x equal to 6, but I'm going to remind you that there was no derivative here. So while that is a cusp, and yes, concavity can change at a cusp on the original, it can't be an actual point of inflection, even if it does switch signs, because to be a point of inflection, you must have a derivative and you must have a tangent line and switch signs. So I'm going to throw that out there just to be careful of when we take a look at that, that technically this is not a possible POI, but you can change concavity here, but you cannot be a point of inflection. Sorry, I'm right on my thing there, but you know what I mean there. So we're going to make sure we put that in. The only actual possible point of inflection is going to happen at this one, where 24 minus 10/3 v is equal to 0, which is where your second derivative is equal to 0. So we'll take a look at that, and we're going to get 10/3 v equals 24, or v equals 3/10. This is the cheap way because remember you don't have to simplify 24 times 3 over 10, which is going to be a fairly large number when you're looking at it. So you're going to have your 6, and then this It's like 36 over 5. 36 over 5, which I believe is a little bit more than 6. Um, yeah, be a little bit more than 6, so we'll just put it over here. So 36 over 5. And so if we go through and we check our concavity, plug in your values for your second derivative. If I pick like 0, which is over here, you're going to end up with 24 over, so positive, positive, and negative, which is going to be negative. Your 6 was undefined for your second derivative. Your in-between section right here, something really close to 6, but a little bit larger, is going to make this negative. And if I put 6 in here, this would be positive, but if I do like 6.1 or something like that, I think it's going to still be positive because we're still really close to it. So that's going to be a negative over a negative, which is going to make that a positive. I'm just double checking my key down here. Oh, actually, no, it's still going to be negative over negative, sorry. And we'll assume that you can use your calculator for that and make sure that we have that and double check what's going on. And then picking like 100 out here, it's going to clearly going to be way negative times that's positive. And then 100 here because it's to the fourth power. Oh, that's what I forgot. To the fourth power is even, so that's going to make that overall positive. So F is going to be concave down and then still down. Remember, that's a cusp, and then it's going to be up. And so taking a look, let's go to our actual graph over here. So this is example 7. And again, notice, and I cheated just like that. I mean, I don't simplify, so I just put that in, and then there's the actual value, 7.2, 8.131. Here's your extrema. That's your cusp right there. And then here was another extrema, which was your relative max that you have. And then I might, taking a look at it before I go to the actual sketching, go back to the original and think about where it was the x-intercepts, 0 and 6. So x equals 0, x equals 6. Those are my x-intercepts. And then we'll look at the limit as x goes to infinity of f of v. Let's think this is going to go to infinity. And then this, you're squaring it, so 6 minus infinity is going to be negative infinity, but you're squaring it, so it goes infinity times infinity is infinity. And then our limit as x goes to negative infinity is going to be, of f of v, is going to be a negative infinity. And again, this one's going to end up being in positive infinity, and a negative times a positive is negative infinity. So it's going to be down and then up when we take a look at it. So going back over here, and so I'm ready to go ahead and sketch, because we also, let me change it to this, is that it's going to go across here at 0. We have a cusp there. We are going to be going down over here to negative infinity, and we work concave down up until we come here, and it never changed concavity. Oh, there was a point of inflection. Was there a point of inflection? There was a point of inflection. That was this one right here. So I forgot my coding. That's my POI right there. So it's going to be down all the way until I get to this. It's going to have a cusp, right? And then it's going to come up, and then it was, let's double check on my graph. We were down, down, and then up after that 16/5 after that point of inflection. So down and then down kind of to there. Sorry, it's hard to sketch with this. And then it's going to be up in some fashion going that way the rest of the way. So it's kind of probably going to be a fairly subtle one. And then we can go ahead and we can turn it on, and we can see that's what our answer is, and we're fairly straight to that. So that's the end of example 7.